Okay, students, hello again. Now we want to start Chapter 9, Part 3, or Section 3, Part 1. We want to talk about evaluating trigonometric functions of any angle. And before we do that, we got to talk about some general definitions of trig functions. We're going to let theta be an angle in standard position. We've talked about that in Section 1. And remember that x and y is a point where the terminal side of theta intersects a circle like this. The 6 trigonometric functions are sine, cosine, tangent. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. Notice we have x over r, right? Which is opposite over hypotenuse. The hypotenuse here is the radius. Okay, and then adjacent over a hypotenuse, which in this case, the hypotenuse again is the radius, and then opposite over adjacent, and then the reciprocal. So it's very easy. These functions are sometimes called circular functions, okay? And the reason they're circular functions is because it has to do with a circle, which we're going to learn in a little bit, that it is a unit circle. But for now, we're going to do that. So let's evaluate a trig functions given a point. Remember that this is x and this is y because it's a point. Okay? On the terminal side of an angle theta in standard position, which we did in section 9.1. So we want to evaluate the 6 trigonometric functions of theta. Now, the important thing to remember is that you see this right triangle? The right triangle, we have a side, which is the x, and we have the opposite, which is the y, and the radius. So if we have x and y, we could remember that the Pythagorean theorems help us find the radius if we have x and y. So the first thing that we're going to do is we're going to remind ourselves, okay, that we have x squared plus y squared is equal to r squared, which is the Pythagorean theorem. Or we can write it like r is equal to the square root of x squared plus y squared, okay? So in this case, we have x and y right here. So in order to find the radius, I'm going to use this one because it's easy. So I'm going to have r is equal to the square root of x squared, which is minus 4, and I'm going to square that, plus 3 squared, which equals 16 plus 9, and of course I have to take the square root of that, which is the square root of 25. So r is equal to 5. We're halfway there. So now we have 3 things that we need so that we could use these functions to find them. First, we have x is equal to negative 4. We have y is equal to 3. And we have the radius is equal to 5, which we just found out. So to find our trigonometric functions, let's change the color. Let's make it green, one of my favorite colors. Okay, so to find the trigonometric functions, okay, and remember, this negative 4 and 3 is over here because we're talking about a unit circle. So this is negative 4 in this case, right? Which we could write it as negative 4, comma, 3, okay? So that's all that we're doing there. So let's find the functions, okay? Let's erase this, okay? And if it doesn't erase, that's okay. We'll just write in green under it. So first, let's write the sine. of theta, which is y over x, right? Well, y over x. I'm just going to write these right now so you could remember. Y over x. Oops, that's not x, it's r. My apologies. It's not x, it's r. It's y over r, right? So y is 3 and r is 5. Wow, that's easy. Now let's do the cosine. The cosine of theta becomes x over r. Well, x is -4 and r is 5. Okay? Then we have the tangent of theta is equal to y over x. So I'm writing y over x, and that equals 3 over -4. You could put the negative on the bottom, in the middle, on the top. It doesn't matter, but I'm writing it like that because those are the numbers we have. Now we could do the other functions. Let's go back to, let's do black. So now, okay, we do black here. We could do the reciprocal of the sine is cosecant. And there's no calculation to do, just flip this thing because it is y over r. So that is just 5 over 3. And then the cosine is secant theta, okay, which is equal to 5 over -4. And then we have the cotangent of theta, which equals -4 over 3. And we just found all the 6 functions of this trigonometric, the general definitions of the trig functions just by knowing a point. So it's very easy to do. So now let's talk about the next part of this section. And let's talk about the unit circle, okay? Well, the unit circle, the first thing we have to do is understand what is the unit circle. And to understand the unit circle, let's write some things. The circle x squared plus y squared equals 1. That means the radius is 1. That's why they call it the unit circle, because it's 1, which has a center at the origin, 0, 0, and radius 1, is called the, guess what? The unit circle. This is going to be important for the next sections that we're going to do. So don't forget this. The values of sine theta and cosine are simply the y coordinate and the x coordinate respectively. And that's because the radius is 1, y over r, and r is 1. So y over 1 is y. And the same goes for cosine. Okay? And respective of the point where the terminal side, let's highlight that. The terminal side of theta intersects the unit circle. Okay? So that's important. Now, so keep that in mind. And let's do a little bit of highlighting here so you know. So that you have the sine of theta is just equal to y. Then let's go to the green here, and we have cosine theta is equal to x. Because the radius is 1. Remember the unit circle. So keep that in mind here. Let's highlight that. R is equal to 1, and that's why it's called the unit circle. So let's go and fill in some things here. Okay, let's fill in this down here. Okay, it is convenient to use the unit circle to find trigonometric functions of quadrantal angles. Okay, so let's just fill in this part. Okay, and it's just the same thing as what we just said. A quadrantal, okay, quadrantal, that's a D. quadrantal angle, okay, is an angle in standard position whose terminal side lies on the x-axis. The measure of the quadrantal angle is always a multiple of 90, and that's extremely important. So we better highlight that because you need to remember this. Multiple of 90 degrees. If it's in degrees, if it's in radians, it's pi over 2. So whenever we talk about a quadrantal angle, it better be a multiple of 90. Well, what are multiples of 90? 0 is a multiple of 90, 90, 180, 270, and 360. So keep that in mind, okay, when you do that. So now let's talk about, okay, let's talk about this part. We're going to use the unit circle now, which is right what we have here. And we're going to use the unit circle to evaluate the 6 trig functions of this one, which is theta equals 270. Okay? So we are going to, okay, let's continue. So we're going to do 270 degrees. Okay? So to 270 degrees, remember that we need to have this first in standard position. Okay, so let's write that little note here so that we could remember what we're doing. Standard position. Remember that we're talking about a unit circle, so r is equal to 1. That's why it's a unit circle. Unit circle, r is always equal to 1. So the other thing to remember is that we need to find out at what point 270 degrees, okay, intersects the unit circle. Okay, so let's draw it out. Okay, let's draw this. Okay, we'll draw it right here. Okay, and let's draw our angle. So our angle is going to go this way. It's going to go here. It's going to go 90, 180, and 270. So that is our theta. Okay, remember that it is going to intersect the circle. Sorry if my circle is not perfect. Okay, so it's going to intersect right here. Well, what is that? That is 0 and -1, because that's what we're trying to find out. Exactly where it intersects the unit circle. Okay, well, what does that mean? That this is x and this is y, right? So we know that x is equal to 0. We know that y is equal to -1. And of course, we already know that r is equal to 1 because it's the unit circle. So to find the 6 functions, or the 6 trig functions, it should be very easy. So let's write it over here. We have the sine of theta. Remember, it's y over r is equal to -1 over 1, which equals to -1. Then we have the cosine of theta, which equals x over r, which equals to 0 over 1, which is equal to 0. Then we have the tangent of theta, which equals to y over x, which equals to -1 over 0. Oops, there's a problem. That's called undefined. Because when you have a 0 in the denominator, it doesn't exist. Okay, well, then the next part should be very easy, because now we just have to flip these things, and we've got the other 3 trig functions. So we have cosecant of theta, okay, cosecant of theta is equal to 1 over negative 1. Oops. Let me go back to this. And let me change it back to this function. Okay. Okay, and back to this. Just give me a second. Just to fix this, go back to here to draw this. And go back to drawing. Okay, there it is. So we have 1 over minus 1 is equal to negative 1. Then we have the secant of theta is equal to 1 over 0. Oops, problem again, which means this one is now undefined. That means it doesn't exist. So what? It's undefined. That is the answer. And then we have the cotangent of theta is equal to 0 over negative 1, which is just 0, because if you have 0 in the denominator, that just makes it 0. And there you go. Okay, let me clarify this picture a little bit. Let's make this. So this becomes 0, this becomes 90, this becomes 180, this becomes 270. Okay, and if we go back around here, it then becomes 360. Remember, if the question asks you in terms of radians, 0 radians, pi over 2 radians, pi, and this one is 3 pi over 2. So if we're talking about these functions here, that we're talking about a quadrantal angle, okay, we have to have an angle that's a multiple of 90. So it's either going to be here, 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 or here. And remember, this is positive going counterclockwise. And if we go this way, now this becomes negative pi over 2, negative pi, negative 3 pi over 2, and 2 pi, right? And it would be negative 2 pi if you go the other way, if you go this way. So don't let that scare you. You guys are doing great. I'm hoping that you are continuing to work hard. And remember, if you have any questions, by all means, send me an email. And any other specific questions we will have in our live chat. Please be safe, be careful,